Today's lesson is about translations. So first of all, we need to know what a translation is. Translation is just sliding an object from one place to another. When we move objects, they're not going to change shape. They should look the same as they did when we started. All we're looking to do is just move them from one place to another. So you're going to see instructions on problems like these that will give you an object like a triangle. They're going to give you coordinates, and they're going to tell you to translate it or move it along something called a vector. Now, a vector is just an amount or a distance and a direction. So the vector tells us which way to go and how far to go. Okay, and this is what our vector looks like. Now, you might notice that the vector is written in XY coordinate form. And this is going to be useful because what we're going to end up doing is we're going to be adding the coordinates for each of our pre-image to the vector, and it's going to end up giving us our image afterwards. So we're going to take point A, and we're going to plot all of these things. So -4, 1, that's A. -2, 1 is B. And -2, -1 for C. So that's always our first step. Let's plot out what they give us. Then we're going to translate it. Now, like we said a second ago, we're going to be adding the X values, and then we're going to be adding the Y values. But every time we want to use this vector that they gave us. That's because we want all of the points to move this direction, this distance. Okay? So, for A prime, -4 plus 6 for its x-coordinate, and +1 plus 3 for its y-coordinate. -4 and 6 is going to give us 2. 1 and 3 will give us 4. So 2, 4, that's where A prime falls. B prime. We're using the B prime x-coordinate, and we're going to use the x-coordinate for the vector. Plus 6. 1 for the y-coordinate, plus, again, the same y-coordinate for the vector. That's going to give us B prime at 4, 4. 4, 4. And last coordinate, C prime, we're working with -2, again, plus 6, which was the vector that they gave us, and -1, plus 3. So C prime is going to fall. -2 and 6 gives me +4 again. -1 and +3 gives me +2. So we're going to move over 4 and up 2 for C prime. And that's what the new location for this triangle is. Notice that it looks exactly the same as it did before. All we did was we moved it along this vector. We moved it 6 over and 3 up. And we did that for every single point. 6 over, 3 up. 6 over, 3 up. So really what the vector looks like here that's what our vector looks like. And we're going to use it for every single point. They all moved that distance, that direction. Alright, so let's look at another problem. I'm going to do this problem a little bit faster. We're going to skip writing out this middle step because, again, all we're doing is just adding the x-coordinate of one of our points to the x-coordinate of our vector. And we do the same thing for each of the points. Okay, so I'm going to skip this step. We're just going to go right from one to the other. Okay, so first of all, let's plot this out. 0, 3, that's x. 2, 2 is y. 3, 3 for z. Connect all my points. Okay, so if we want to find x prime, we're going to add 0 and 2 to get 2. Then we're going to add 3 and negative 4, which will give us negative 1. 2, negative 1. That's x prime. Y, we're going to add 2 and 2 will give us 4. 2 and negative 4 will give us negative 2. So y prime is at negative 4, negative 2. Y prime. And last, z. 3 and 2 gives us 5. 3 and negative 4 gives us negative 1. So z prime, 1, 2, 3, 4, 5, negative 1. Z prime. Connect all of my points. Okay, so we moved this original triangle, x, y, z, along vector positive 2, negative 4. So we moved everything over 2 and down 4. Over 2, down 4. Over 2, down 4. Okay, exactly what it told us to do. It gave us a length and a direction. Let's see if we can work backwards now. Here, they give us shapes, and they tell us where it started and where it's going to end. The directions say things like, describe the vector. So we know that we're just moving a shape from one place to another. So, if we're looking at figure 1, mapping onto figure 2, what we're looking for is, what would we have to move this point along to make it go from here to here? This is easy enough to do by just counting. Okay? When we do counting, we want to make sure that we follow the x, y directions like we would with plotting a point. What I mean by that is this. I want to count my x direction first, because that's going to be the first coordinate of my vector. So, to go from 1 to 2, I'm going to highlight a point on 1 and highlight the same point on 2. I'm going to draw my vector in just so I can see where I'm going, and then I'm going to count my x direction. How many units over did I move left or right? I moved 1, 2, 3, 4 in the negative x direction. So I moved negative 4. That's my x coordinate for the vector. And then I'm going to count my y direction. How much up or down did I move? I moved 1, 2 in the positive direction for y. So my y coordinate is positive 2. Easy enough. Let's look at this second example. From figure 2 over to figure 3. So the same process. Pick a point on figure 2, pick the same point on figure 3, and we want to see how do we get from figure 2 to figure 3. Well, again, I'm going to list my x direction first. So which way did I move, left or right? I moved 1, 2 in the positive x direction. So that's my coordinate for my vector. And then I moved 1, 2, 3, 4 in the positive y direction. So it's going to be positive 4 for my y coordinate. And that's it. That's how we describe a vector. That's how we move vectors or move along vectors. That's how we describe what a vector looks like by looking at an image.